So, hello everyone. How are you guys doing today? Everyone fine? Today was a long day. My name is Antons. I work in company MikroTik, and today I will talk about 60 GHz range improvements and multipoint capabilities. So, before we start, let's remind us how other frequencies, especially used in point-to-point links, perform. Everybody who has used 2.4 GHz or 5 GHz knows about interference. That's driving us nuts. It's impossible to make reliable links nowadays using those frequencies, especially high-speed links. 2.4 GHz penetrates better through objects, but there is low channel counts and other limitations. 5 GHz, more speed, DFS radar detection, rapidly increasing channels and things like that. But 60 GHz, let's talk about elephant in the room. It won't go very far. There's oxygen absorption and low distance because of that. But it's the highest throughput and it's relatively free spectrum. I hope everyone has seen this picture. That spike in the middle, it's 60 GHz. It shows attenuation to kilometers. So basically, 60 GHz is the worst frequency for data transmission. Data transmission in high distances, if we have to be correct. But because of this absorption, we are not picking up interference from other links because they are attenuating. So that what works against us works for us. So everybody received, I hope everybody received gift bags. You have these nice devices inside them called wireless wire. Those are two devices. Already pre-configured radio link. So basically you just have to plug it in and use it. It's a 4-core CPU. 4-core ARM CPU, very powerful for not only routing, not only bridging, but for other things too. It only takes 5 watts of maximum power consumption, and range is improved to 200 meters or more. So if you update your devices to latest RC versions, you should see range improvements. Please give us feedbacks, tell it how it works, how this was achieved. It wasn't just increasing power, it was calibrated antenna patterns. Those devices also support beamforming and point-to-multipoint support. So channel bandwidth at 2.16 GHz. It uses very large channels, 3 of them are available right now. So you can set up 3 devices and cover pretty much high distances. Total radiated power is under 40 dBm, so it's legal for indoor use and on outdoor use in point-to-multipoint setups. There are 32 antenna elements working together to make one beam, for connection. And the device sweeps between 64 pre-written antenna patterns that are made from those antenna elements. Wireless coverage is close to 180 degrees. How is that possible? We have showed that it's 60-degree antenna, but it's covering 180 degrees. The answer is beamforming, of course. And the price for this kit is under $200. If you want to put more devices, you can buy them separately. Normies probably have showed already the new devices, but I will just remind you a bit about them. So, VAP60G, you can buy a separate device. It comes the same hardware. It's made for CPE device usage. You can use it for point-to-point installations or just as a client and connect to existing 60 GHz access point. And it comes with license level 3 and price is under $100. And you can buy also an access point. This is the same device, only difference is it has level 4 license for point-to-multipoint support. It supports 8 connected clients, so you can connect 8 clients to this device. And of course, our new addition, LAG60G kit. This comes the same way as the wireless wire. It's a kit of 2 devices, already pre-configured. At the exhibition hall, we have set up a link. You can come play with that, try to cover it up and see how it works. We have put up 1 gigabit full duplex link. It's compliant with fixed point-to-point regulations in Europe. Antenna gain is over 30 dBi, and total radiated power is under 45 dBm. And price for 2 devices is just under $300. So how to configure those devices? If you want to configure them manually, there are 4 modes. Access point bridge, it's for level 4 devices as access point, bridge, station bridge, and sniff. Those modes act as same as regular wireless modes used in MikroTik devices. Configuration is under interface V60G menu. You can find it in Vimbox under interface wireless and select V60G tab. And minimal configuration is SSID and correct mode. We did some comparison with other MikroTik devices to see what we have done, what we got with this one. So at first we tried to compare with wireless devices. We ran 2.4 gigahertz dual chain boards with 11 cards. Set up benchmarks and tried to repeat that with wireless wire kit. Wireless wire kit was limited by Ethernet interface, not by wireless interface. Those tests are throughput tests coming from Ethernet, coming out from Ethernet. So basically you're getting 1 gigabit per second full duplex speeds anytime. So we replaced those devices with cable, ran some serious testing with cable, and then tried to replace the cable with wireless wire kit. And we get pretty similar results. We were getting pretty much same results at packet size 256, and up we get the same results. So that's where the name was born, wireless wire. You're replacing wireless, wire with wireless devices. Our presentations will be later available, so if you don't catch something, don't worry. All tables will be available in presentations afterwards. So we also draw a graph, not very interesting graph, going horizontally. And we also added point-to-multipoint support. Experimental support is starting from current version 641, and we are always pushing new changes in RC releases. So if you have testing setups, please give us feedback. Are we doing right? Are we doing wrong? What can be improved? Requirement for access point as well for license, as I told you before. You can get your license if you have paid registration. You will get one free. You can use that for testing, or you can buy access point device or buy license and get into testing of point-to-multipoint. Connected clients are showed as individual interfaces. It allows easier connection, easier management, and also you can apply some management rules to clients, as well as you could configure, for example, Ethernet interfaces. So we also did some coverage tests with connected to clients. We set up middle access point in the middle, connected two clients at distances very close to 100 meters, and tried to move them apart. The further we got, the less space we had. Actually, we didn't finish the test, we ran out of space. Afterwards, we retested and got very close to 180 degrees. So. And all those tests were done with 450 megabits per second full duplex traffic for each client. So basically, it's 1.10 gigabits per second throughput. And we also done tests with more than 2 clients. This screenshot shows performance with 4 clients, each receiving 400 megabits, 200 megabits full duplex. Each version comes with new improvements. First versions of wireless wire modes were called master and slave. Later, we renamed them for more commonly used MikroTik universe names like bridge, access point bridge, and station bridge. Also, we added put stations in bridge. This allows the access point to treat new interfaces into the same bridge as the previous one. And also isolate stations, so it's basically not allowing your clients to talk to each other, but just talk to access point. We also added MCS rate support under MCS4, so it allows you to go more further than previously. And also we added SNMP support, so now you can monitor your wireless link with SNMP. Also, we recalibrated antenna sectors. So now it goes 200 meters and more. Just upgrade your router OS, check how it works. Please give us a feedback. Next versions will come with RSSI, so you can monitor signal strength. Previously, it was just signal value showed in percentage. And also, we will add TX power control. So you can turn down power if you don't need all the power for example, short distances, for few meters to few. So we will do live testing today. I hope it works well. But before that, we will just discuss how the testing should be done. It's preferred never to run testing tools on the devices. Why? You're testing device performance, not wireless performance. If you're testing wireless performance, set up your link that you are sending through it, through the devices, not from device to device. Check for bottlenecks before connecting, before testing. For example, if you are testing, you're getting wireless wire kit, connecting it to your 10 megabit per second connection at home, running speedtest.net, you will still get 10 megabits per second. It won't go faster that you have improved one place. Wireless devices will suffer from interference. With 60G, it's much more less noticeable, but still, if you run a lot of devices in the same room, you can suffer from interference. And test at power outputs that will be used on device. If you are testing wireless devices, for example, 5 gigahertz devices with very low power output, on the table, it may not show the same results as it will show on real link. Some testing software. Bandwidth test, it runs on router OS, on PC. There's a Windows client. You shouldn't run it on board because you will use only one core for testing. It will be one core, packet generating performance, not wireless performance. Please keep that in mind. A lot of people, even a lot of very experienced trainers and users are still using bandwidth test to test max throughput. If you're testing it from one PC to other PC, it's okay. If you're testing from small MIPS-B board to another MIPS-B board, you're just doing one core performance test, not bandwidth test. Traffic generator. This is a tool we will use today. I will show you a very easy way how with one stream you can just generate traffic for transmit and receive. iPerf and iPerf3, if you can run it on PCs, it's multi-platform. Of course, speedtest.net, other tools. Keep in mind there's a lot of professional solutions, professional tools to use. But RouterOS can be used as one of those tools if you use traffic generator correctly. So, while we were talking, there was a traffic flowing from one device to another device. Currently, I have one device on the table, and two devices stick to the columns at exhibition hall. So right now, we are generating traffic. Keep in mind that there's a lot of people. Devices are not aligned properly. They just stick to the column. So right now we are getting point-to-point performance close to 1 gigabit full duplex. Device is looking somewhere else. This one is looking somewhere else. But beamforming is helping to achieve those speeds. If I move it a bit, we will see a little bit of speed drop right here, and later it just gets back. So beamforming kicks in, and everything works. Same on the other side. See, a bit drop, and everything's back on. So let's make it more interesting. As I told previously, never test on devices. Currently, I'm doing that. I'm running test on device. I'm running traffic generator, but I'm running traffic generator correctly on very powerful device. Keep in mind, this is 4-core ARM CPU. It can do a lot. So we have two interfaces available. One is active, other one is not. So let's turn another one. So clients are treated as separate interfaces, as I told previously. Let's turn the other one on. And it's connected. So, and let's talk more about testing setup. So basically what we used, we made traffic generator packet template. We put in IP destination. IP destination, we put our own IP address because we are setting traffic in loopback mode. We are sending it to ourselves. We are sending it to ourselves through another device. So IP gateway, it's a device on the other end. And we are also adding UDP destination ports, so more ports is used for testing purposes. Later we make a stream, two traffic generator stream. In stream we add speed and packet size is used for test. After that we can just run traffic generator with start. Keep in mind, if we use start command, traffic generator will run always until you reboot device. If you have configured something wrong, you can just lock yourself out. To stop, you can run two traffic generator stop. You can also use quick command before running, or the start command, and just put smaller traffic amount through the link just to check if it works, if your packet template is correct. Same goes for multipoint testing. We can make two streams. We make two packet templates, one for one device, another for other device. We set IP destinations, IP gateways, and source ports. You can add source port just to make layer 3 connection happy, but you can skip this step as well. And later you just make streams. I have a bit different stream. This one was 400 megabits. I have 450, so I can just export, show my configuration. And let's start our traffic generator to two devices. So let's open interfaces. We have one device, and we have another device. So right now we are getting 900 megabits per each client. So basically 1.8 gigabits per second. If you have any questions, you can come to my table later on. We can discuss it later because we are slowly running out of time. I can show you how to use traffic generator, tell more about patterns used, how they are created, and what to expect in future. So thank you very much for your attention. Thank you.